Hello, welcome to the Argo course. My name is Mohammed and I'm very happy to be here. In the previous session, we talked about Canary deployment strategy and we learned how it works. But in this session, I'm going to talk about analysis in Argo rollouts. We can analyze our applications. We can define some metrics to check the status of the application. And if everything is good, we can switch to the new version of the application completely. It's possible to analyze the application in Canary deployment strategy as well as blue-green deployment strategy. Let's go to the note. In this section, we have three important CRDs, custom resource definitions. The first one is analysis template. An analysis template is a template spec which defines how to perform an analysis, such as the metrics which it should perform, its frequency, and the values which are considered successful or failed. For example, I'm going to measure the success rate of the application. And if the result is 80% or more, the analysis will be successful, for example. Otherwise, it will have failed. So we can define these metrics using analysis template. The second CRD is cluster analysis template. A cluster analysis template is like an analysis template, but it's not limited to its namespace. It can be used by any rollout throughout the cluster. And the last one is analysis run. An analysis run is an instantiation of an analysis template. Analysis runs are like jobs in that they eventually complete. Completed runs are considered successful or failed. And the result of the run affects if the rollout's update will continue, abort, or pause, respectively. Very good. First of all, I'm going to use analysis and the blue-green deployment strategy. Let's go. It's possible to use analysis and the blue-green deployment strategy before and also after the promotion. So we have two different options here. The first option is pre-promotion, and the second one is post-promotion. First of all, I'm going to talk about pre-promotion. But what is that? A rollout using the blue-green strategy can launch an analysis run before it switches traffic to the new version using pre-promotion. This can be used to block the service selector switch until the analysis run finishes successfully. The success or failure of the analysis run decides if the rollout switches traffic or abort the rollout completely. Let's go to the terminal. We have a directory here called blue-green analysis, and we have multiple files here. I'm going to use these files for the blue-green deployment analysis, and in the first section, I'm going to use pre-promotion analysis. Okay. We have a file here called rollout with analysis.yaml. Let's open it. We have 3 different objects in this file. The first one is a rollout. This is the rollout of the application. I'm using an image here called blue-green. This is our application, and this application has 2 different versions, version 1 and version 2. I'm using an environment variable called HTML_name, and its value is app-v1.html. It means that I'm using the first version of this application, and this is the container port. And as you can see here, the strategy of this rollout is blue-green, and I'm using 2 different services. The name of the active service is rollout blue-green active, and the name of the previous service is rollout blue-green preview. And auto promotion enabled is true. It means that when I switch to the new version of the application, the rollout will be promoted automatically. And I have this image on my local machine, so there is no need to pull it. Therefore, image pull policy is never. And also, we have 2 different services here. This is the active service, and this is the preview service. Very good. And also, we have another file here called ingress.yam. The backend service of this ingress is rollout blue-green active. So this is our ingress, and I'm using Nginx ingress controller for this example. Very good. Okay. First of all, I'm going to apply these 2 files without pre-promotion analysis. So I type kubectl apply -f rollout with analysis and ingress. Very good. So let's go to Argo Rollout dashboard here. This is our deployment. The number of replicas is 4. Very good. But what is the host name? blue-green.demo. So in the browser, I type http blue-green.demo. So we are in version 1 of the application because the environment variable of the application is app-v1.html. As you can see here, auto promotion enabled is true. So it means that when I modify this item here, app-v1.html to app-v2.html, and then I apply this file, it means that the rollout will be promoted automatically. So if I go to Argo Rollouts dashboard, as you can see here, active and preview services, both of them points to revision 2. And if I refresh this page, we are in version 2. Okay. I want to show you something. In this time, I'm going to change this value with with an invalid value. For example, app-v3.html is an invalid value for the application. So we will receive an error because this is an invalid value for the application. So if I apply this rollout again, we are in revision 3 and both of them, active and previous services, point to the new version. But when I refresh this page, we will receive an internal server error. So we have an error in the application because the value of app-v3.html is invalid. So this is not desirable for us. In this time, I'm going to use the pre-promotion analysis to check the health status of the previous service, because the previous service always points to the new version of the application, to the new replica set. I'm going to use it before switching to the new version of the application. Therefore, the pre-promotion analysis is an ideal option here. But before that, I'm going to delete the current analysis. Very good. We have multiple providers in Argo Rollouts analysis to define some metrics for the analyzing purposes. One of these providers is the Kubernetes job object. We can use jobs to define some metrics. If the result of the job is successful, the rollout will be continued and we will switch to the new version of the application. And if the result of the job is failure, the rollout will be aborted and we will back to the previous version of the application. Very good. This is the official documentation of Argo Rollouts. And we have a section here called Analysis, and these are multiple providers that we have in this section. Prometheus, Datadog, Job, Web, CloudWatch, and the other providers. In this time, I'm going to use Job provider. Therefore, I copy this example here and paste it into this file. This definition has no API version, kind, and metadata, so I need to find these fields. Yes. Okay. The kind is analysis template. It means that I'm using analysis template to define some metrics. Its name is success rate. I don't need to modify it because it's good. And let's change the name of the metric from test to success rate. Very good. The provider is Job, as you can see here. And we have a block here called metadata that has two different fields, annotations and labels. Annotations and labels defined here will be copied to the job object. I don't need to use annotation in this example, but label is good. But let's modify this label and let's replace foobar to analysis equals pre-promotion. Very good. The backoff limit is 1. I don't need backoff limit. So I replaced it with 0. Let's change the name of the container from test to success rate. Very good. Okay, I'm going to show you something. In this example and in this scenario, I'm going to use our custom image. As you can see here, we have 2 other files in this directory, app-successrate.sh and the Docker file. App-successrate.sh is a shell script and is responsible to measure the success rate of the preview service or active service. We are using pre-promotion analysis here. So I'm going to measure the success rate of the preview service. So if I open this file, as you can see here, I'm using a loop. And this loop will be run 5 times at 5 seconds intervals. And in this loop, it will try to connect to the previous service or active service. We are using pre-promotion analysis, so the value of this variable will be the name of the previous service. If 3 or more of 5 requests return 200 response code, the shell script will return exit 0. Otherwise, it will return exit 1. And also, we have a file here called Docker file. And I'm copying app-successrate.sh into that image. So I have built this image already. So this image is available in my local machine. So you need to build this image using these 2 files, app-successrate.sh and Docker file. If I type Docker images grep-i analysis. As you can see here, this image is available in my local machine. And as I said earlier, I'm using this image to measure the success rate of the preview or active service. Let's back to the rollout. So I changed the name of the image to analysis. I'm going to run that shell script into this container. Therefore, I changed the command to bin bash, comma, -c. And I'm using args to run this shell script into this container. Very good. The restart policy is never, and also this image is available in my local machine, so there is no need to pull this image. Therefore, I type image pull policy equals never. Very good. As you saw earlier in this shell script, we have a variable called service underlined URL. This is an environment variable, and its value is the name of the previous service or active service. In this example, I'm going to use the name of the previous service for the pre-promotion analysis. So I type env. The name of the environment variable is service URL. Very good. And its value is the name of the previous service, the URL of the previous service. HTTP equals rollout rollout-blue-green.preview.default.svc.cluster.local and its port. Okay. Very good. I saved the file here. Okay. First of all, let's modify the value and replace it with v1.html. Under strategy.blue-green, we have a new field here called pre-promotion analysis. I type templates and I type template name. This is the name of this template. The name of this template is success rate. So I'm going to use pre-promotion analysis for this rollout, and the name of the template that it's going to use is success rate. Very good. I saved the file and let's apply it. I type kubectl apply -f rollout with analysis. Very good. Let's back to our application, and if I refresh this page, I'm waiting for this new rollout. Okay, and if I refresh it, yes, we are in version 1. Everything is good. In this time, if I refresh and if I modify this value and replace it with a new value, for example, with2.html, Argo Rollouts will create a new replica set, but it will not switch to the new version of the application because we have a new field here called pre-promotion analysis. So it will analyze our application before switching to the new version of the application using this template. And this template, in this template, we are using an image called analysis, and we have a shell script that is responsible to measure the success rate of the previous service. And if everything is good, we can switch to the new version completely. So I changed the value from app-v1 to app-v2.html. Let's apply it. Okay. If I go to Argo Rollouts dashboard, as you can see here, we have an analysis here, and its status is running. We are in revision 1 yet. I'm waiting for its status. If the status is successful, we will switch to the new version, and otherwise we will back to the previous version. So its status is successful, so we are in new revision because the status is successful, and if I refresh this page, we are in version 2. So everything is good. I type kubectl get pod. This is a pod related to the analysis. So I type kubectl logs this pod, and yes, the success rate is 5 of 5. Everything is good. This shell script was responsible to measure the success rate of the previous service, and the success rate is 100%, and everything is good, and so we are in new revision. In this time, I'm going to use an invalid value here. For example, v3.html. This is an invalid value for the application. In this time, we will not switch to the new version of the application, and the rollout will be aborted, and we will back to the previous version of the application because this is an invalid value for the application. I save it, and then I apply it again. Let's go back to Argo Rollouts dashboard. This is the new analysis, and its status is running. I'm waiting for its status, its final status. The status will be failure, so we will back to the previous version before switching to the new version, because this table service is in revision 2. Okay, as you can see here, the status is failed, and the new version of the application is scaling down, and it's aborting. So if I refresh this page, we are in version 2. So there is no problem. Yes, revision 3 is terminating, and active and previous services, both of them point to revision 2, because revision 3 was an invalid revision and its analysis status is failed. I type kubectl get pod. Status is error, and if I get the logs of this pod, the success rate is 0 of 5. So it means that we have an error with the new version of the application and the rollout aborted and we are in the previous version. It was about pre-promotion analysis before switching to the new version of the application. The next option that we have in the blue-green deployment strategy is post-promotion analysis. A rollout using a blue-green strategy can launch an analysis run after the traffic switch to the new version using post-promotion analysis. If post-promotion analysis fails or errors, the rollout enters an aborted state and switches traffic back to the previous stable replica set. When post-analysis is successful, the rollout is considered fully promoted and the new replica set will be marked as stable. The old replica set will then be scaled down according to scale down delay seconds, and its default is 30 seconds. Okay, in this time, I'm going to use post-promotion instead of pre-promotion. So, the first step is deleting the current rollout. So I type kubectl delete -f rollout with analysis. Very good. And then I open the file and let's replace app-v3 with app-v1. Very good. In this time, let's use post-promotion. So I changed the label from analysis equals pre-promotion to analysis equals post-promotion. The backup limit is 0. The name of the container is success rate. The image is analysis. Very good. But in this time, I'm going to use the name of the active service instead of previous service as the environment variable. So I grab the name of the active service, rollout blue-green active, and I replace it here. Rollout blue-green preview with the rollout blue-green active.default.svc.cluster.local. Very good. So this is a post-promotion analysis, and the environment variable of service URL, its value is the rollout blue-green active. So it will try to connect to the active service 5 times at 5 seconds intervals. And if 3 or more requests return to 100 response code, the shell script will return exit 0. Otherwise, it will return exit 1. And also, I'm going to replace pre-promotion with post-promotion. So I remove pre and replace it with post-promotion. Very good. I save the file and let's apply it. I'm waiting for the new rollout. So I click on it and waiting for the new rollout. Okay. And we are in version 1. In this time, we are using post-promotion. So when I change this value, app-v1, for example, to app-v2.html, Argo rollouts will create a new replica set and switch the traffic to the new version because auto promotion enabled is true. And then it will run an analysis run with this template. And if everything is good, the new replica set will be marked as stable. And if not, we will back to the previous version. Okay, let's change the value from app-v1 to app-v2.html and apply the file. The active service points to revision 2, but revision 1 is the stable version until the final status of this analysis. As you can see, this is a post analysis. Its status is running. I'm waiting for its final status. And if everything is good, the stable version will be in version 2. Yes. Its final status is successful and we are in revision 2 and the new replica set is marked as stable. So it was a post-promotion analysis. So we are in revision 2. Very good. In this time, I'm going to use an invalid value, for example, v3.html. So this is an invalid value, and if I apply it, the new replica set will be created and active service points to this revision. But the result of analysis will be failed because of that. The rollout will be aborted and we will back to the previous version. So I apply the file again. Yes, active service points to revision 3, but revision 2 is a stable revision until the final status of this post analysis. Its final status will be failed. Because of that, the rollout will be aborted and we will back in revision 2. Yes, as you can see here, revision 3 will be scaled down in 20 seconds. And now active service points to revision 2. So we are in revision 2 without any problem. And revision 3 is terminating. Very good. It was about post-promotion analysis. Analysis templates may declare a set of arguments that can be passed by rollouts. The args can then be used as in matrix configuration and are resolved at the time that analysis run is created. For example, I'm going to use 2 different arguments here. The first argument is the name of the namespace, default namespace. And the second argument will be the port. Okay? So I'm going to define 2 different arguments for this analysis template. Because of that, under a spec block, I define another block called args. I type name equals service port. And its default value is this. And also, I'm going to define another argument here called service namespace, but it has no default value. If I want to call this argument, and also this argument, I need to use this syntax. First of all, let's remove default from here, and I type args.service namespace in this placeholder, remove the port number and replace it with args.service port. As you know, service port has a default value, but service namespace has no default value. Because of that, I need to pass it and I need to give it a value into the rollout. So, when I'm going to call the template, I type args name, and its name is service namespace, and its value is default. Service-port has a default value, so it's optional to define it, and it's optional to give it a default value into the rollout. But service namespace has no default value, and it's required to give it a value into the rollout. Because of that, I defined an argument into the rollout called service namespace, and I gave it value called default. So, let's change this value. Very good. And first of all, I'm going to delete the current rollout and apply a new one. So I'm waiting for the new rollout. In this time, I'm going to use analysis templates arguments. And we have two different arguments called service port and service namespace. Okay. Let's go back to the file and change the value from v1 to v2 and apply it again. We have an analysis run that it's running. If everything is good, we will switch to the new revision and stable, and revision 2 will be marked as a stable revision. So I'm waiting for the final status. Yes, very good. And the revision 2 is a stable revision. So in this time, we used analysis template arguments, service port and service namespace, and we used them into the analysis templates definition with this placeholders and with this syntax. So if you give it a default value, it's optional to give it another value into the rollout. And if the argument has not a default value, for example, service namespace has no default value, it's required to give it a value into the rollout. Very good. It was about analysis templates, arguments. We have another important CRD here called cluster analysis template. A rollout can reference a cluster scoped analysis template called a cluster analysis template. This can be useful when you want to share an analysis template across multiple rollouts in different namespaces and avoid duplicating the same template in every namespace. Because of that, you have to do two different steps. The first step is using a kind called cluster analysis template. And when you want to call the template here, I'm calling the template name success rate. You need to define that this is a cluster scoped template. Because of that, type cluster scope equals true. It means that the success rate analysis template is a cluster analysis template. Okay. In this time, I'm going to use analysis for the Canary deployment strategy. And also, in this scenario, I'm going to use a different provider for the Canary strategy instead of job provider. I'm going to use web provider. This provider makes a request to a URL, and that URL must return a JSON content. This request can be a GET or a POST or a PUT request. So that request must return, that URL must return a JSON content. For example, we make a request to a URL and its JSON content is like this. For example, data equals OK equals true. For example, this is a JSON content. Okay? In this provider, we have two different conditions. Success condition or failure condition. We can use one of them in this provider. For example, I'm going to say that this analysis will be successful if success condition is .data.OK equals true. If data.OK equals true, this analysis will be successful because I'm using success condition and .data.OK equals true. Or if we use another condition like this, failure condition, and if .data.OK equals false, this analysis will be failed. So we are defining some conditions in this analysis template. I'm going to do this scenario for the Canary strategy. We have a new directory here called Canary Analysis, and we have multiple files here. First of all, I'm going to delete the current rollout related to the blue-green deployment analysis. So I type kubectl delete -f blue-green ingress and blue-green rollout. Very good. So now I apply the ingress related to the Canary and rollout related to the Canary 2. Okay. Let's open the rollout. This definition and this file must be familiar for you because we learned the Canary strategy in the previous session. In this rollout, we have a list of steps, and these are the percent traffics related to the Canary. And also we have a series that its selector points to this rollout. Very good. The host is rollout setWait.demo. This is the rollout-setWait that we have. These are the list of steps, and we are in revision 1. So I type rollout-setWait.demo, and we are in version 1. Very good. As I said earlier, I'm going to use web provider. This provider makes a request to a URL, and that URL must return a JSON content. And I'm going to use a condition for that analysis. Because of that, I'm using a Flask application and Flask script, and it must return a JSON content. We have a file here called analysis-app.py. This script's task is to take a value as a URL, and in a loop that repeats 5 times at 5 seconds intervals, it measures the responses of that URL. If it returns 80% or more with a status code of 2000, it will return a JSON content like this. Data OK equals true. Otherwise, it will return a JSON content like this. Data OK equals false. So this script returns a JSON content. I'm going to open a new terminal. And go to this directory to run this Flask application. First of all, I'm going to rename its name from analysis-app.py to app.py. Very good. Let's run it. So I type Flask run --port. I'm going to use a different port and --host. Very good. And this application is running in my local machine. Let's open another terminal to try to connect to this URL using curl. I'm using post method, so I type curl -x post, and the header is content type equals application -json, and the data is URL, and the URL is rollout set weight.demo. HTTP equals rollout set weight.demo. Okay. And HTTP localhost support / measure success rate. Very good. Okay. I'm waiting for its final status. It will return a JSON content. Yes, as you can see here, it returns the JSON content like this: data OK equals true. So, first of all, this script takes a URL. The URL is this. This is the data. HTTP rollout set weight.demo. This is our URL. Takes this URL and in a loop that repeats 5 times at 5-second intervals, it measures the responses of this URL. And if it returns 80% or more with a status code of 2000 response code, it will return a JSON content like this. Otherwise, it will return a JSON content with data OK equals false. For example, I'm going to use an invalid URL like this, and it will return JSON content like this: data OK equals false. So this Flask script returns a JSON content. Very good. I'm going to use this Flask script in my analysis template as a web provider. Let's do that. I go to Argo Rollouts documentation. As you can see here, we have a provider called web, and I copy the content from here. I'm going to use it in rollout with analysis file as the first object. Very good. It has no API version, kind, and metadata, so I need to copy from blue-green deployment. Very good. The name is success rate, and the name of the metric will be success rate. We are using a provider called web, and also we are using success condition instead of failure condition. I'm going to talk about the result in a few seconds, so don't worry about it. But what is the URL? This is the URL related our application. As you know, my application is running in my local machine, and its URL is this. This is the URL related to my application. The web provider makes a post request to this URL, and this URL returns a JSON content like this. Okay? This is the IP address of my local machine, so I copy it and paste it here instead of localhost. Okay? Timeout seconds is 20 seconds, but I'm using a sleep in my Flask application. Because of that, I need to increase timeout seconds here. 50 seconds is good. But what about headers? As you know, the only header that I'm using is content type. So instead of authorization, I use content type, capital T, and its value is application/JSON. I need another field called JSON body because I'm using a data here, so I need JSON body. The key is URL and the value is this. This is the JSON body, and we have an expression here called JSON path, and its value is .data.ok. The value of data.ok will be true or false. So I'm using this expression, and the content of this expression will be assigned to a new variable called result. Result is a new variable, and its content is the value of data.ok. So the result is a new variable, and its value is true or false. Okay. I'm using post method in my Flask application, so I need to define it here. The default method is get, but I'm using post method, so I need to define it. Post method, very good. I think everything is good. Okay. But how can we define this analysis into the rollout? We can define the analysis templates into the Canary strategy using two different ways: background and inline analysis. But what is the background analysis? Analysis can be run in the background while the Canary is progressing through its rollout steps. it means that analysis template will not be n steps. So if I want to define a background analysis for the Canary deployment strategy, I need to define it within Canary block. I type analysis and templates. And template name is success rate. So the name of the template is success rate. I'm defining a background analysis. So this analysis is not within our steps. Let's save the file. Okay, and let's apply it. So we are in revision 1. In this time, I'm going to switch to the new version of the application. Let's apply it again. And as you can see here, an analysis is running at the background and it's not in our steps. I think we have a problem here. So what is the problem? Because one part is terminating from revision 2 and the status is failed, the status of analysis. What is the problem? Oh yes, the URL is not correct. Rollout set wait. I forgot to place T here. Okay, this is correct. Rollout set wait the demo. Okay. Let's apply it again. I need to switch back to the previous version first. We are in revision 3 and the first version of the application. Very good. In this time, let's switch to the new version. And the URL is correct in this time. Okay. Very good. The analysis is running in the background and we are in step 2 of our application. If I promote the rollout manually, these steps are running and the analysis is running too in the background. Yes, the status of the analysis is successful and our steps are running too. As you can see, the status is successful. So I'm waiting to complete all the steps of the Canary strategy to switch to the new version completely. If the analysis failed, the rollout will be aborted and we will back to the previous version, as we saw earlier. I'm waiting for 1 minute to switch to the new revision completely. So it was about background analysis, and this analysis is not within these steps, and it's running in the background. Very good. We are in revision 4 completely, and if I refresh this page, we are in revision 2. Okay. It was about background analysis. So another way to use analysis for the Canary deployment strategy is inline analysis. Analysis can also be performed as a rollout step, as an inline analysis step. When analysis is performed inline, an analysis run is started when the step is reached and blocks the rollout until the run is completed. The success or failure of the analysis run decides if the rollout will proceed to the next step or abort the rollout completely. So, in this time, I need to delete the current rollout. And let's create a new one. But in this time, instead of defining a background analysis, I'm going to use an inline analysis. Because of that, I delete these 3 lines from here. And I'm going to use this analysis as the 3rd step. As you can see here, I'm using analysis as a step, and the analysis is in the steps, and it will run as the 3rd step. Okay, let's save the file and apply it. We are in revision 1. Very good. As you can see here, we have a list of steps, and the 3rd step is analysis. The name of the analysis is success rate. An analysis run is started when the step is reached and blocks the rollout until the run is completed. So let's switch to the new version of the application. For example, update v2.html, and I apply it. In this situation, I need to unpause the rollout manually. Okay, and we are in a step 3, and analysis is running as the 3rd step. I'm waiting for its final status. Let's see what's happening. The success or failure of the analysis run decides if the rollout will proceed to the next step or abort the rollout completely. So it was successful, and we are in the next step, and everything is good and okay. I'm waiting for the rollout to completely to switch to the new version completely. Okay, in this time, I'm going to use an invalid value for the application. f-v3.html is an invalid value for the application, and the rollout will be aborted. Because of that, I need to use this analysis as the last step here. So I type it here as the last step of this Canary strategy. Let's apply it here. Let's wait for the revision 2. I'm waiting for revision 2. Okay, very good. And let's apply it. Okay. We have a list of steps, and the analysis is the last step that we have here. We are using an invalid value for the application, and I accept to receive a failure here as the last step, and the rollout will be aborted, and we will back to the previous version of the application. First of all, let's unpause the rollout. Okay. I'm waiting for the analysis. Analysis is the last step of this Canary deployment. Internal server error because of an invalid value for the application. We are waiting for 1 minute to go to the next step. This is our new revision, and this is the previous version. I'm waiting for the analysis. Okay, we are in analysis, and let's see what's happening. The analysis is running, and its final status will be failed, and the rollout will be aborted because of an invalid value for the application. I'm waiting for the final result. Yes. As you can see here, the status of this analysis is failed, and revision 3 is terminating, and the rollout is aborting, and we are switching back to the previous revision because the analysis status is failed. So we are in version 2 completely. Okay, it was about inline analysis. That's enough for this session. Have a good day and see you soon.